We're going to take a look at factoring here in order to solve some quadratic equations. So again, this would be a prerequisite skill for this class, but I often find students feel really rusty on this. So what we're going to start with is called the zero product property. Let me show you. It'll make more sense if we just take a look. So we have a quadratic equation. It's quadratic because it has an exponent of 2 as the highest degree. Now, we want to start by factoring this. Now, it's an equation this time. It equals 0. So we're going to be able to solve this. But if you can factor, we're going to learn several methods as we move forward for how to deal with a quadratic equation, how to solve it. But the first and easiest is, can you factor the thing? Now, we're going to see that there's, if you remember, this gets harder if there is something in front of x squared other than a 1. But when it's a 1, it's pretty straightforward. So this is the game where we're saying, okay, I need two numbers that multiply together to get -6 and add together to get 1. So if I can find those two numbers, then I already have this thing factored. And so do you agree these are my two numbers? If I multiply these, I get -6. If I add them, I get +1. And so that's it. I've already found them. So I'm going to knock this down to, so there's two x's, which is making up the x squared. And I'm going to put my two numbers in there. Now it equals 0. So we have factored this, just like the number 15 can be factored into 3 and 5, two numbers that multiply. We've done the same. If we multiply these two numbers back together, we get back to x squared plus x minus 6. Okay, now here's where the zero product property comes in. Now we have it factored, but this equals 0. Now if either, I don't know what this number is in here because there's an x plus 3, I don't really know the number. But if this thing turns out to be 0 and it's being multiplied by another number, the whole thing would be 0. So if this is 0, the whole thing is 0. If the right turns out to be 0, the whole thing is 0. And so what I need to do is set those individual pieces equal to 0. Okay, now if either of these things turns out to be true, the whole thing is 0. So I'm going to solve them individually, and I'm going to get two answers. So because it's x squared, we're going to get two different answers. I factor it down first and then solve. Okay, so let's play this game again. So pause if you want to do it yourself. But there's a 1 in front of here, so this is the basic game. I'm looking for two numbers to multiply to get -6 and add to get -5. And it will be these. Do you agree with that? That adds to get -5, multiplies to get -6. So okay. Okay, so here's what I've got. Now, in order to solve it using the zero product property, I'm going to set each of those individually equal to 0, which I forgot to do over here. Okay, solving this, I get x is 6 and x is -1. So we got two answers. Okay, so I don't really see anything special about this. Should I just let them do it? Yeah, same game. So we're looking for two numbers to multiply to get 15 and add to get +8. Is there a point that there aren't any? No, there are. So I'm just going to get rid of that. So if we did this, brought 15 over here, so my two numbers would be 5 and 3. So those multiply to get 15 and add to get 8. So I've got x plus 5, x plus 3 equals 0. Okay, we solve that. We get x is -5, and x is -3. Okay, let's try again here. Again, pause it if you want to give this a shot yourself. But now we're looking for -21. Two numbers that multiply to get -21 and add to get -4. So my 2 would be this. Now set them each individually equal to 0. And I get those two answers. Okay, same thing here, but we have a different way to factor this. Do you remember how to factor x squared minus 9? It has a square root on the front and a square root on the back. So when you factor that down, you get two x's. And you can take, so I would tell a student, if you saw this, you're going to get the two square roots, going to write them twice. Now this only works if there's a negative in the middle, but there is. And so here's how it factors. Now, same thing as before, I'm going to set each individual part equal to 0 and solve. X is 3 and x is negative 3. Now, if the factoring is really difficult for you, we're going to go through all of them, all the different approaches rather quickly here. But I have more slow-paced videos for Algebra 1 if you want to see any of that. Okay, so same thing here. I've got square roots on the front and the back. So I'm going to write those square roots. Now, it had the negative in the middle, so this does factor, and it gets opposite signs. So the opposite signs, if you FOIL this back out, they make the middle would drop out. You're going to get a negative 5x and a positive 5x. They would just drop out. So that's why this pattern, you have just square roots on the front and the back and the negative in the middle. Okay, now I'm going to set them individually. I'm going to jump ahead here. Do you see how? If I set them individually equal to 0, this is what I would get as my two solutions. Okay, now this one, we're moved a little faster than I expected here. We've got several issues on this one. So what we're first going to do here is anytime you have, well, we have x to the third. So at this point, the only way we would know how to do this is we're going to take out a GCF. So look, notice that they're going to take, there are two things. They all share an x, so I'm going to take a GCF first. So when you factor, GCF is always the first step. If there is one, you always start with that. The second thing I don't like about this one is anytime they start with a negative, take the negative as well. It's going to make any other factoring very confusing if you don't take the negative along. So we take out a negative x, and now we have this left behind. Now, we aren't done. If you're doing the zero product property, you want to factor down as far as you can go. And 3x squared plus 5x plus 2, we got to see if we can factor that. Now, what's harder about this is you can't simply just do the trick we did before, because the 3 is going to make it more difficult. So some people can just do this in their head and kind of guess their way through it, and that's an acceptable method, but I'm going to show you what's called the AC method. And so the A is what's in front of the x squared, and the C is at the end. I'm going to multiply those together. I get 6. Okay. Now, let's find two. We're going to play the same game, but it's going to have a little different outcome here. Let's play the same thing. I'm going to take those two, make 6. Now, I'm going to find two numbers that multiply to get 6 and add to get 5. So, and the signs matter. So, positive 6 and positive 5. So, do you agree with those two? Okay. Now, I don't know if they... Yeah, they are doing it this way. So, yeah, this is good. So, what you do next is you take these two numbers you found and you change the 5x into those two. So I'm going to make this 3x plus 2x right there in the middle. And you say, well, did I cheat or do something wrong? No, I didn't. 3x plus 2x go back together to make 5x. It's the same thing. So now what we're going to do here is we're going to pull a GCF out of the front and a GCF out of the back. So on this front one, you could pull out a 3x. On this back one, you could pull out a 2. And you know you did it right if you've created two of the identical same term. I've got x plus 1 and x plus 1 in each of those, so this is correct. Now, what you're really doing is you're pulling out a GCF of x plus 1, but if you just want to know how this, what you get as an answer, you make the x plus 1, the match becomes one of the solutions, and the 3x plus 2 come together to make the other. What you're really doing is you're pulling out an x plus 1 as a GCF. You're withdrawing those from each of them. But what it looks like in practice is this. The match becomes one, and everybody else comes together to make the other. Now, I put a bracket on here, but I don't really need it. So here I have it factored down. Negative x, x plus 1, and 3x plus 2 equals 0. Now, let's set them all equal to 0. And do our zero product property. Now solving each of these, this is still going to get x is 0, x is negative 1. Now I did this in one step, but I sent the 2 over divided by 3. So I have 3 answers there. All 3 of these would be solutions. Okay, now I really recommend you try one on your own, but I'm going to help you with this. Oh, they didn't give us AC method on this one. This is a little unfortunate, but okay. Now I'm going to factor this second term here. It's not AC, it's just the same. I'm looking for two numbers that make 10 and add to get 11. So it's these two, if you can read my handwriting. It's just 10 and 1. Now I wish it was AC method because that's something students struggle with. That was pretty straightforward. Now we're going to set each of these parts equal to 0. Maybe, if you remember to do it. Okay, so this one's solved. That's one solution. The second is negative 10. X is negative 1. Okay, now the zero product property is super helpful. There's another way to approach these called the square root property. Let's just talk about it. If I can just get x squared, like there's no other x terms, I just have x squared. If I can get x squared by itself, I can then just take the square root of both sides. So I'm going to try to see if I can just get this x squared all alone. So I would subtract 1 from both sides and get 6. Now I've got x squared, and I'm going to divide both sides by 4. I'm going to get this x squared all by itself. This is a strange one. Did I do this right? Yeah, I would have started off with some better numbers here, easier numbers, but so far so good. So I've got x squared all alone. Now if I have a square root, I can solve that. I can just square root both sides. Those are opposites. So that makes x. And now remember, this is, I don't know if I've mentioned it yet in this series of videos, but sometimes they want us to think of what's called the principal root, and they don't want the plus or minus when you take a square root. So the square root of 9 is technically plus or minus 3. There's some reasons why sometimes they'll ignore the minus and sometimes they won't. Well, I'll talk more about that later when we get to functions. But so here they want the plus or minus. So if you square root something, it is plus or minus the square root of 3 over 2. Now this is complicated because we usually don't want a square root in the denominator. I'm going to show you this. I don't even know if we're ready to tackle this. You can take a fraction that's under a square root and make it 2 individual square roots. But if you do that, remember, you don't want a square root on the bottom. I hope you've seen all of this before. So what you would do is a trick where you would rationalize the denominator. Do you remember all this? You'd multiply the top and the bottom by the square root. And so this would all come together to be the square root of 6 over 2. Okay, now there's a lot there. Let me see. Did they even do it? Yeah, they did. They jumped right to it. Oh, I guess I can see. Yeah. Yeah, they got there a different way, but yeah, they did do that. Okay, so let's use the square root property again. Now, this is different that all of this is being squared, but that's okay. We're going to get that problem area all isolated. So I'm going to just divide both sides by 3 to get this entire square alone. And I'll get x minus 4 squared equals 5. Now I've got a square on one side, so I can square root it. That would take care of that problem. Do it to one side, you got to do it to the other. And you'd get x minus 4. Those are opposites, so they knock each other out. Equals plus or minus the square root of 5. So with quadratics, you've got to remember the plus or minus. That's a big deal here. Now we're not quite done. We don't have x by itself, so I'm going to add 4 to the other side. And I would get this. Now remember, this is two answers. This is 4 plus whatever the square root of 5 is. It's 4 minus whatever the square root of 5 is. Okay. Now we have another method here called completing the square. We're going kind of quickly here. Completing the square, I think the other approaches are good, but sometimes you can't do them. Here's in practice. We're going to see something, I think in the next video, called the quadratic equation. The quadratic equation will always work. So most students don't wind up, if they have the choice, they're not going to complete the square. But it's a clever trick, so let me show it to you. So what we want to do is find a number that would allow us to turn this into a perfect square. And I'll show you that in a minute. But the first part is, let's just get this 5 out of there. He's not helping. He's not factorable as it stands right now. So I'm just going to get him out. Now here's completing the square. What you're going to do, and man, they started with a difficult one right off the bat. What you're going to do is you're going to take half of the middle number and then square it. So again, I would definitely do the quadratic equation on this, but I'm going to take half of that middle number, that's in front of the x, and I'm going to square it. And if you're really clever, you'll see why. But this is just a math trick that they knew that this is always going to create something that easily factors. So if I have this here, I've got now 9 over 4. Okay, so I've taken half of that middle number and then I squared it. Now here's why. I'm going to add that number to the left. You say, well, you're not allowed to do that. Well, you can, as long as you also add it to the right. So what's happened here is I've found a very special number because this number will allow me to factor. But if you add it to one side, you have to add it to the other. Okay, now we can now factor this side over here. This is why we picked this special number, is because now it's a perfect square trinomial. The front has a square root and the back has a square root. And because of the numbers we chose, the middle is 2 of those. So let me show you here. The way they've done this is right, but what I want to show you is we chose something where if I take the square root of the front and the square root of the back, so back here to this, if I take the square root of this and the square root of this, do you remember this pattern that it's going to create 2 of that middle term? You're going to get a negative 3 halves x there. You're going to get a negative 3 halves x there. If you put those together, it's going to be negative 3. Now, they shouldn't have started with a fraction one here, in my opinion, because this is confusing enough, unless you've seen it before, which maybe you have, but a fraction was a bad choice. But okay, so this special trick allows you to factor it where you've got a square. And why is that helpful? Because we can use that square root property to just square root both sides. So again, they've started with a very confusing one, so I hope you've seen this before. But you can square root both sides, so you get this on the left. Now they've square rooted this side on the right. Finally, we just send the 3 halves over. And this is 2 answers. This is plus or minus, so this is 2 different numbers. Okay, let me help you through another one unless you feel pretty comfortable. Man, I guess they're assuming we've had this before, which it is in an Algebra 1 book, so you've probably seen it. So they've already moved this guy over to the other side. He wasn't helpful. I couldn't factor with him, so I just sent him out of the room. Now I'm going to take that middle term and I'm going to cut it in half. So negative 6 divided by 2 is negative 3. Okay, so I'm going to cut him in half and then I'm going to square it. And so this is going to be the number 9. Now I am specially choosing this number because it will allow me to factor this. But I can't just make up a number. If I add 9 over here, I've got to add 9 to the other side to keep this equation balanced. Now here's what we've done. This is a perfect square trinomial, which factors down to be this. Again, I have more on that. If you don't even understand that factoring pattern, go back to the old stuff. But here's what I've got. Now, why is this helpful? Because I now can use that square root principle where I can just square root this side and square root that one. And I'll get x minus 3 equals plus or minus the square root of 22. Now add 3 to both sides, and I get this. Okay, I was expecting a little bit more there, but so I think we're going to tackle the quadratic equation in the next video. I know, again, that's not a whole lot on completing the square, but those two, that is it. So again, if you're having trouble with any of those factoring patterns, go check out the Algebra 1 videos.